Okay, in today's lesson, the objective is to be able to solve multi-step equations in one variable. So we're going to continue with talking about the properties of equality, meaning whatever I do on one side of the equal sign, I must also do to the other in order to keep my equation true. And we're going to take it a little bit further today and create equations rather than just solve them. But before we get into that, I want you to check Google Classroom. There's a little quiz on there. I just kind of want to see where we're at midway through this chapter. So go ahead and take that quiz, pause the video, do that, and then come back. Okay, so if you think back to last year, you learned how to combine like terms. I know Mr. Rose uses a method of circles and squares, so we're going to do our circles and squares. We circle the terms with the variable and put squares around the terms without variables. Now remember, terms are separated by plus and minus. I want to keep this minus sign with this 23. So if I am looking at my equal sign, we're wanting to continue to use the properties of equality here. Whatever I do on one side of the equal sign, I know I must do on the other side. So in order to get rid of this minus 23, I know that the inverse operation of minus would be to add. So I'm going to use the addition property of equality. It says whatever I add to one side of the equal sign, I must also add to the other. I added 23 over here, making that 0, so I must add 23 on this side, making this 28. Then I'm left with 5m plus 2m on this side of the equal sign. These are like terms. I can go ahead and combine. 5m plus 2m gives me 7m. I just add the coefficients since they both have the variable m. Now the division property of equality tells me that if I divide this side by 7 in order to get rid of that 7, I must also divide this side by 7. So m is equal to 4. And we can plug it back into our original problem to check. 5 is equal to 5 times 4 minus 23 plus 2 times 4. 5 times 4 we know is 20, minus 23 would be negative 3. Negative 3 plus 8 is in fact 5. So 5 is equal to 5. It works out correctly. Now, some of you may have at the very beginning just went ahead and said, okay, I can use the commutative property to rearrange these in a different order, putting 2m by 5m, go ahead and combine and get 7m minus 23, and that's not incorrect. You would still come up with the exact same solution. Okay, so that was what you did last year. This year we want to take it a step further. If you look back at this, the standard here that we're trying to do, it says create equations in one variable. So we got to take it a little bit further. I'm going to give you the word problem, and you have to be able to decipher what they're looking for, write the equation, and then solve. So it says Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. And Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts and no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? So let's think about what they told me here. We know that she bought something for her niece, and she bought something for her nephew, and the combination of the two things that she bought for them, or what she bought for her niece and what she bought for her nephew, gave her a total of $67. Okay, well, that's not really going to help us, just having what she spent on her niece plus what she spent on her nephew. So let's go look at what she bought her niece. She bought her niece a t-shirt and 4 bumper stickers. So the niece got a t-shirt. We don't know that price. And then she got 4 bumper stickers that cost $1 each. So we know that she spent $4 on bumper stickers. Then we come over here to her nephew. Well, her nephew wanted 2 shirts and no bumper stickers. We still don't know the cost of a shirt, so we're just going to put 2T to represent 2 times the price of 1 shirt. And we know that was a total of $67. So let's make sure that this makes sense. We've got the price of a t-shirt, because her niece got 1 t-shirt, plus the $4 spent on bumper stickers, plus 2 times the price of a t-shirt, since he got 2 t-shirts and no bumper stickers, gave us a total of $67. So at this point, we could use the commutative property and rearrange them. We could use the associative property and the commutative property to not only reorder, but we could regroup. What I'm just going to do is I'm just going to drop the parentheses and I'm going to say, okay, 1 t-shirt plus 2 t-shirts. Okay, let's try to solve this problem. We're going to solve an equation that contains a fraction. Now, there's 2 ways that we can go about doing this. The easiest thing that I think to do is use the property of equality, the multiplication property of equality, and just get rid of the fractions right off the bat. I know that 12 is divisible by both 4 and 3. So what I would do right off the bat is I would multiply both sides by 12. So let's see what happens when I do that. 12 over 4 is what I end up with. I have 12 times 3x over 4 minus 12x over 3 equals 120. Now, the reason I would do this is because 12 over 4 reduces and 12 over 3 reduces. We know that 12 divided by 4 is 3, so I have 3 times 3x minus 12 divided by 3 is 4, so 4x equals 120. 3 times 3 is 9x minus 4x equals 120. So I have 5x equals 120. If I divide both sides by 5, I have x equals, what would that be, 24? So x is equal to 24. That is one method. Now, maybe you're not all familiar with the fact right off the top of your head that both 4 and 3 are factors of 12. I think everyone knows that, but maybe that just doesn't pop in your head right off the bat. So there's another way that we can do this problem. It might be easier for you if you think of going ahead and combining these. They both have x's in them. So let's go ahead and combine our fractions. Well, we know in order to combine fractions, they must have a common denominator. So it's still kind of the same thought. What could I make both of these into to give them that common denominator? Well, they're both factors of 12, so I guess you still have to know that to be able to do this. So what would I change 3/4 to make it something over 12? Well, I times by 3, so I've got 9/12 x minus, okay, I've got, this is basically 1/3 x. So how could I convert 1/3 into something over 12? Well, I know to get from 3 to 12, I times by 4. So to get from 1 to whatever's supposed to be up here, I've got to times by 4. So I've got minus 4/12 x equals 10. So now I can go ahead and just combine. 9/12 minus 4/12 we know is 5/12 x equals 10. In order to get rid of a fraction, I multiply by its reciprocal. Its reciprocal, it's just it flipped over. Whatever I do on one side, I must do on the other. So I would go ahead and reduce this to 2. 2 times 12 is 24. So 24 is equal to x. Or I could say 10 times 12 is 120. 120 divided by 5 is 24. And there you have it. That pretty much sums up what I wanted to cover with you for today. Remember, if I give you a problem in decimal form, then you can give me the answer in decimal form. Or if I give you a problem and we're dealing with money, you can give me the answer in decimal form. But any other time, I want you to write your answer as a fraction if, it doesn't come out as a whole number. Tomorrow